Hello, and welcome to today's webinar titled Hacker Interrupted. At this time, all participants are in a listen-only mode. If you have a question at any time during the presentation, please type it into the Q&A box located on the left-hand side of your screen. We will have a live Q&A session at the end of the presentation. I would now like to introduce today's guest speakers, David Koretz, Vice President and General Manager of Mykonos Software. David Koretz is the founder of Mykonos Software, the leader in deception-based cybersecurity under Mr. Koretz's leadership. Mykonos was named a 2010 Gartner Cool Vendor, winner of the Wall Street Journal's Technology Innovation Award in 2011, and selected for the 2011 CNET 16. From age 14, he has founded 6 technology companies, including Blue Tie and Inventive, and still serves on the board of directors of both companies. Mr. Koretz also serves on the board of directors of Earthlink, the Dean's Council for the RIT School of Computing, and the board of trustees of the Rochester Institute of Technology. Mr. Koretz is the inventor of a dozen U.S. technology and cybersecurity patents and a frequent speaker on technology. Kyle Adams, Chief Architect of Mykonos Software. As architect and lead developer for Mykonos, Kyle Adams has final responsibility for code quality and technical excellence. Mr. Adams is a graduate of the Rochester Institute of Technology with a bachelor's degree in computer science and a minor in criminal justice. He wrote his first password protection software at age 10, started hacking incessantly, and writing his own encryption software by age 14. An Ajax expert and enthusiast, Mr. Adams has worked on scores of web application projects as a freelancer and entrepreneur. I would now like to hand the call over to David.
Thank you very much. And thank you, everyone, for joining. What I want to do is spend the next 20 minutes talking a little bit about a new way to think about web application security. We're going to actually show you a live hacking demo from a hacker so you can get a sense for how hackers are hacking websites today and how the system can respond. So to start, the problem, to give you a scope sense, is about 70% of all threats today exist at the web application layer. And not surprisingly, about 3/4 of all companies have been hacked in the last 2 years. Now, those are the 3/4 that knew about it. Our view is the actual numbers are a lot higher. We just got done with a presentation where the head of NSA made the comment that for NSA, the average hacker is on their site 6 to 9 months before they even know they're there. And so you can imagine that the average company and how effective they might be in recognizing it. And the other thing to think about is that there aren't one type of attacker. And so what I want to talk for a second about is a little bit about the different types of attackers that are hitting your sites and why you need to react and think about them differently. And so the first thing you've got is IP scanners. These are automated tools that are looking for a specific vulnerability. They might be looking for something like an exploit against a specific WordPress site. And so what it'll do is it'll actually go around the web, hitting hundreds of millions of sites looking for that one specific vulnerability. And if it hits it, it generates a list of all the sites that are vulnerable. The problem with that is it makes hacking incredibly efficient. It's the equivalent of having a robot that would allow a robber to go check every single door and window in the neighborhood. And so what we're actually able to do is start to go a step further and actually intercept those IP scanners and actually deceive them and tell them that the hole doesn't exist even if it does. The second thing we think about is targeted scanners. Scanners like GrendelScan, Metasploit, O2, scanners that are attack tools. And the problem with a scanner is that it allows an unsophisticated hacker to do very sophisticated things. What you'll find is both pen testers as well as bad and malicious actors will use targeted scanners to go against your site and actually look for hundreds or tens of thousands of vulnerabilities in a very fast and automated way. And so what Mykonos will do there is actually use deception to inundate those results with false positives and actually ruin the quality of the results so the hacker's results are useless. They have to hack manually. The third thing we worry about is botnets. These are where attackers are using automated scripts. Where we've seen these being the most damaging is when somebody has found a vulnerability and now they're looking to scale it up to do maximum amount of damage in a short period of time. And so we'll talk about how we actually intercept the botnet and break the botnet on the fly. And then finally, we'll talk about human-based hackers. Specifically, we'll get into APT and how you think about stopping a hacker before the problem starts. But first, I want to take a step back and talk about what's happened in the industry, because 2011 was a very significant year. It used to be that hacks were mostly about embarrassing somebody. It was egg on your face. And what's happened is 2011, we had the first multi-billion-dollar web app attack. The Sony attack is estimated to have cost Sony $4 billion. Probably more interesting is that they actually had to take their network offline for 23 days. So how many companies could survive a 23-day closure? Imagine if that was a utility and they were taking their network offline and customers without power 23 days, or imagine if it was a bank and you had no access to cash. Very few businesses could survive that type of outage. And there's nothing that tells us that Sony's going to be the last attack. In fact, we think there's going to be more multi-billion-dollar attacks happening as the years go through, and I'll talk a little bit about why that's happening. Interestingly, we go to RSA conference every year, and we ask every single executive there, how would you know if you have a hacker on your website right now? And I'll open that question later to the group. I'd love to hear how people on this call think about it. But the amazing thing is 80% of the CIOs that responded said we would have no way of knowing if a hacker was on our site in real time. And the other 20% said, well, that we would check the log files, meaning they would know about the attack after the damage had been done. Well, that's kind of like giving somebody pictures of their house long after it's burned down. What you need is a smoke alarm. You need a way to be able to see an attacker before the attack actually happens, and we'll talk a little bit about how to do that. So the way Mykonos works is by using what we call intrusion deception. And the idea is that if you can deceive an attacker, you can actually get in front of the attack and see it before it happens. And there are 5 phases to every attack. The first phase is reconnaissance. And attackers looking for holes, they're going around your website, and Kyle is going to show you later exactly how a hacker does that. And once they find something, the second phase is they're going to script that attack. They're going to try to write something so they can target it. The third phase, they're going to actually execute the attack. They're going to run the attack against your site and try to do the damage. The fourth phase is they're going to automate it. They're going to try to figure out, how do I get this onto a botnet? How do I distribute it? How do I get it at scale so I can do maximum impact? And then finally, there's a maintenance phase. Over time, your company is going to close the holes, and the hacker is going to try to figure out how to keep those holes open. So what Mykonos does is inject hundreds of little tiny fake deception points into the code at serve time. So as the code is being pushed down to the bad guys as well as your customers, there's extra things in it. And those things allow us to detect an attacker by their bad behavior before the attack. The moment we do that, we start to track them. We actually track everything they do, and we become like a DVR, and then start to profile the attacker to actually measure the threat level of the attacker and what they're trying to accomplish and the type of hacker they are. And then finally, we respond. And 90% of web app firewalls run in a passive mode. They're just log files. 100% of the Mykonos devices actually block active attackers. We're going to show you how you can block them. We're going to show you how you block different types of attacks. We're going to show you some fun stuff as well. So just to dive in a little bit more technically, we are an inline proxy that sits directly in front of your web application servers. And I'm going to give you a few examples of what I meant by deception. So one example is people do things like session hijacking. What they're going to do is try to tune a URL string to be able to hijack a session and actually use that to get in. But 20% of the top 100 sites have some form of session hijacking vulnerability. So what we did here is we actually injected fake code, that debug equals false, was actually added by the Mykonos appliance when it's pushed down to the customer at serve time. And what that allows us to do is be able to go out, and when the attacker modifies that, we now immediately know we have a bad actor without false positives, and we can do it before the actual threat happens. The second thing we do is we actually can do things like inject into the code. One of the biggest attacks we're seeing today is Sql Injection, where an attacker is going out and modifying the forms on your site, trying to inject a SQL statement that will get that database to spit back credit card records or personal information or other things they might be looking for. And so here what we've actually done is injected a fake hidden input variable into the code itself, into the form. So when an attacker tries to manipulate the code, they're actually tripping over something that doesn't exist. And when they do that, they're identifying themselves. And then finally, we also think about the width of deception, but the depth of deception too. So how do we actually start to waste a hacker's time and cost them money? So this is an Htaccess file. It's a Linux system file. Most of you on the call are probably familiar with it. Well, it shouldn't be exposed, but it often is. So if a hacker calls a site where Mykonos is protecting it and they ask for the Htaccess file, we will block the real one, but return a fake one down. And if the hacker is sophisticated enough to understand what this file does, they might see, hey, there's an HTTP password file here. And if they call that file and they know how to traverse hidden directories, we'll again respond, this time returning back a fake HT password file with a list of usernames and encrypted passwords. Now, if the hacker is not sophisticated, they're going to be done. They're not going to know what to do with them. But if they're really good and they know how to use tools like John the Ripper, which is a desktop decryption tool, they might be able to break the encryption, and we'll actually let them log in to a fake file using that broken encryption. Now, none of that is real. What they've done is they've just burned through 12 or 15 hours of their time attempting to hack a site, and they've never actually talked to the site at all. What they've been doing is communicating with a Mykonos appliance that's been baiting them into wasting their time and starting to change the economics of a hack. Now, once we detect them, we actually track them, and this is another big differentiation point is you're probably used to, most of you, IP-based tracking. I'm going to block an IP, and I might have an IP block list. Well, this is actually device level. So we actually, as a hacker is doing browser-based attacks, inject persistent tokens, think of it like a super cookie, onto the attacker's PC. And we then start recording everything they do. But there's also script-based attackers, people that aren't running browsers, and there are also people that might try to evade by spooling up a new virtual machine or if there are more advanced attackers. And what we'll do is we'll actually also fingerprint their device all the way down to the machine level. The reason we do this is because we want to become a DVR. So you'll notice this is a real screenshot from Mykonos Appliance. You'll see Jack26. Every hacker gets a name because what we start doing the moment we tag their device is recording every single thing that they do. And you'll notice that all of those things that I mentioned earlier are now being recorded and escalated, and Kyle will show you this in real time in a second. So the moment we do this, then the question becomes, well, how do we respond? As I mentioned earlier, only 10% of web app firewalls actually run in block mode. 90% of them just let the traffic flow through and just log the data afterwards. 100% of the Mykonos devices run in block mode. I'll talk about a few things that we can do, some of the fun things we'll show you later. One thing we can do is we can block an individual device. So if you've got 50,000 customers sitting on an IP address, we can block one bad actor that might have an infected PC without affecting anybody else on that IP. The second thing we could do is if somebody's running a botnet against you, we can actually intercept with what's called a forced Captcha, which you might see if you check out at ticketmaster.com, where we'll actually intercept and push a Captcha warning and actually break the botnet on the fly so that an automated script will no longer work. If we have a hacker who's running too fast or they're being persistent, we actually might slow their connection down in real time and actually force them to hack in slow motion, so it might have taken an hour now takes 20 hours. We might actually simulate that the application broke. So we'll start throwing random 404 and 500 errors to confuse the hacker and waste their time. And if they're in a financial services app or another app where there might be a login, we can actually force a logout and immediately break the session. But we can also do fun things like warn them, and Kyle's going to show you a cool example of what we do there. All of this data is starting to be recorded real time to this dashboard. So and companies are increasingly worried about visibility, and specifically, how do I see the hackers that are on my site? This actually shows you in real time how many hackers are hitting your site, how many attacks are happening, and probably most importantly, how many we're preventing. And all of this is web-based. It can be accessed from anywhere, but it can also be integrated directly into your data center management tools. We have a full CLI. If you want to plug into SEM tools, we also have full SNMP capability and SMTP if you want to plug into your other data center tools. And all of this is available in reporting so that you can actually show all the way up the chain exactly what's hitting your site and show them visibility they probably have never seen before. So Mykonos, from a platform perspective, runs across a huge range of platforms. We have a software appliance that can be installed in any hardware you want. It's an ISO, and it can run on HP or Dell or IBM hardware, and that can sit in front of your own internal data center. We also recognize that as more of you virtualize your environment, you want Mykonos to run alongside those virtualized applications, and we actually have a virtual version that we ship as well. And then finally, we have a cloud version. We just shipped an Amazon Web Services environment recently so that if your application lives in the cloud, Mykonos will live alongside those applications in the cloud as well. Now, the real exciting part of this is that each of these systems is recording every single attacker and building a real-time database, not of IPs, but of devices and everything bad they've done. Well, when you look at attacks that are hitting across multiple sites, specifically APT, what you worry about is you've got 4 data centers, maybe you've got some virtualized applications, and maybe you have a cloud instance or 2. Being able to see that an attacker hitting your German data center is the same one hitting your US data center, is the same one hitting your virtualized instance, and the same one hitting your cloud, that's something you can do when you start to pull together a shared database using Mykonos. And probably the best way to think about it, one of our customers is Bertelsmann. They own Brown Printing, and they deployed Mykonos in about 20 minutes. They had never seen a hacker on their website before, and in the first 30 days, they saw and stopped 300 attacks. And so we've been fortunate enough to win a bunch of awards across the industry. Most recently, Wall Street Journal named us the Information Security Award winner alongside IBM Watson and an organ that could build itself. So pretty good company. And so what I want to do now is actually get to the really fun part, which is Kyle is going to show you how a hacker hacks a website and how the Mykonos system responds. Kyle?
Thanks, David. So what I'm going to start with is just give you an introduction to the security monitor, which is what David had just gone through. Just a second. Okay, so I'm going to just give you a quick walkthrough of the security monitor. And basically what this does is it provides real-time activity for the administrator. Everything in Mykonos is automated, but if you want to go explore some of the activity that's going on the site or investigate a specific threat, you could do that through this tool. So what you're seeing right now is basically some summary information. This is what you see as soon as you log into the security monitor. So this left box right here, this is showing you all the individual attacks that we've observed. And it's also showing you what the top 5 attacks that we're seeing right now are. And we break these down between high, medium, and low. So low would be basically an unsophisticated attack, medium being requiring tools or a little bit of skill, and then high being extremely complicated. Then we have in the middle box, this is more people-centric. So these are the actual individual unique hackers that we've identified on the site. So each one of these hackers might be responsible for multiple incidents. And we'll give you a weighted list of the top hackers on your site. And this is weighted by how aggressive they are and how complicated and how sophisticated the attacker is. And then off to the right, you'll see all of the different counter responses that we've deployed so far to deal with the threats, as well as the top malicious countries that are hitting your website. And then below that, we're giving you kind of just a week level view. So this is every day of the week, how many incidents you've been experiencing, how many hackers have been on your site, and as well as how many just average users have been navigating around. So the top one is over 30 days, and you can actually extend that out to be up to a year. So I'm going to switch over to generic electronics. This is our fake electronic retail store that we use for demos. And I'm going to launch a couple attacks against this site and show you how Mykonos detects those attacks and how it responds to them. And these are very similar to the techniques David was describing in the previous slide. So kind of the first thing an attacker is going to want to do when they're trying to hack a site is just kind of navigate around and understand what all the pages look like. They want to know where all the inputs are and what might be vulnerable. They don't want to get flagged at this point, so they're not going to start doing anything that might be detected by signatures or something like that. So we're going to navigate around, and again, I'm just trying to figure out what all the different page layouts look like. So I can see there's some product listings, there's the home page, there's a shopping cart, some registration forms, things like that. But as I'm navigating around, I notice there's a lot of information being passed around in the URL string. So kind of the easiest possible attack I could take is just start modifying these values and see what happens. So I see that there's this value at the end, M4 equals true. Well, that's pretty easy. We can just try false and see what ends up happening. So I'm going to submit false. And what you'll notice is nothing really unusual came back. And I was hoping for an error message or something like that, but nothing really happened. And it's not surprising because generally you have to try thousands of different vectors before you find the one that's actually going to work. So I'm going to keep navigating around the site and see what else I can find. But what you'll notice is Mykonos has already detected me as an attacker, and it's thrown up this warning dialog to basically say, hey, we know you're up to no good, so you better knock it off. And the use case we generally see with this is you've got a legitimate user on your site, there may be a paying customer or something like that. You don't want to just flat out block the user. Maybe they did something by accident, or maybe they're just barely breaking the terms of service. So we throw up the warning, and hopefully that discourages them from continuing with the malicious activity. But let's say that that didn't deter me and I want to keep going after this site. Well, I could keep modifying that value all day long and it will take forever because if I have to try 1,000 different things, it's just going to be a huge waste of time. So instead, I'm going to try running an attack script. And what this is going to do is just try a whole bunch of different Sql injection attacks against the M4 parameter. So we're going to go ahead and launch the script, and it's going to test each of these vectors and come back and tell me whether it found anything. So right now it's testing each one. It's saying, I tested it, nothing was found. I tested the next one, nothing was found. But all of a sudden my script starts to break. It's coming back saying, hey, I got some weird result back. And that could be good news. It means it might have actually found a Sql injection vulnerability. So we're going to go ahead and actually try one of these attacks that failed and see what the script is seeing. But what you'll notice is I'm getting a Captcha. So now I know why my script stopped working. Every time it tried to launch an attack, it ended up hitting this Captcha, and it wasn't able to actually complete the attack. So it's not that it actually found Sql injection vulnerabilities, it's just that my script stopped working. So I'm a human, I'm sitting here, I can go ahead and fill this out. The script would be stuck, but that's not a problem if you're sitting in front of the computer. So I just solved the Captcha, and it went away. And kind of as a joke for the RSA conference we did a little while ago, we built this other response. It's called Cloppy. And he comes up and he says, hey, it looks like you're an unsophisticated script kiddie attempting to hack this website. Would you like help with SQL injection, cross-site scripting, or session hijacking? Obviously, you wouldn't do this to a real hacker, but we thought it was pretty comical. So I'm going to go ahead and dismiss Cloppy, and we're going to try another type of attack. So this time I'm going to go and mess around with the HTML on the pages. So we're going to go to the login dialog, and I'm going to use a tool called Firebug to actually select one of the inputs. So I'm going to go and select the registration form, and I'm looking at all the HTML that makes it up, and I can see that there's a couple hidden inputs in here. Specifically one called SQL index with a value of 4, and that looks really interesting because it has the term SQL in the name. So maybe this is getting used in a SQL statement, I'm not sure. But we can go ahead and try launching a SQL injection attack against it and see what happens. So I'm going to put an attack in there, and we're going to fill out the form and submit it. And nothing really interesting came back. Again, not surprising. I'd have to try a whole bunch of different things before I finally find that one that's going to work. So I could keep trying this one, but let's navigate around the site and see what else you might be able to find. But what you'll notice is now every page that I'm trying to load is loading dramatically slower. So after Mykonos had detected me modifying query parameters and then modifying hidden inputs, it figured I was pretty aggressive and had activated the slow connection. And there's two reasons we do that. One is to slow down the attacker and kind of frustrate them, make the site just respond slowly and be sluggish in general. And the other reason is so that we can have more time to analyze what they're trying to do and how skilled they are so that we can activate a more appropriate response for this user. But let's say, again, I don't mind hacking in slow motion, so we're going to go attack a different form. So I'm going to add an item to my cart, and I'm going to mess around with the HTML behind the cart. And again, you'll notice how slowly everything is loading, so it's already starting to get a little painful. So we selected the input. I'm looking at my HTML, and again, I see this SQL index parameter, so we'll try a different attack this time. Let's just give it a bunch of characters. My last one wasn't successful, but maybe this time I can get it to spit out an error at least. So we're going to change the value, and I'm going to select Update Quantities and see what comes back. And again, everything is just running very, very slowly. So still loading, and finally it comes back. But I'm not really seeing anything here either. Again, not surprising, hacking a site can take hours and hours and hours, so we're just going to keep looking around and seeing what else we might be able to find. So I'm going to click on another product. So we're going over to the car electronics section, and again, you'll notice it's taking quite a while. Still loading. And what's interesting is that instead of getting back a product listing like I was expecting, all of a sudden the home page comes back. And that's really strange because, I was going to go add another product item to my cart and try to mess around with the HTML again, but for some reason I can't get to the products. And let's try getting over to the shopping cart and seeing what else I can get possibly in there. So I clicked on the shopping cart, and unfortunately, I'm still back at the home page. So what ended up happening is Mykonos actually activated a break application response. So after it had seen me kind of ignoring all these warnings and just keep going after the site, not getting deterred at all, it had activated the break application, which strips out all of the inputs, all of the cookies, all of the query parameters, all of the form inputs. And basically what ends up happening is whatever site we're protecting is going to respond however it's going to respond to not having any user input whatsoever. And there's a wide array of different things we've seen. Some applications will come back with errors. Some will come back with validation problems. Others will come back and say, hey, you need to be logged in to get to this page. But in general, the site will stop responding the way the hacker expects it to respond. And there's two good things about this. One is we're hoping that the attacker will believe that they've broken the application. So maybe they think they've been successful and they'll go move on. Another advantage is that if they're running a tool like a vulnerability scanner, the scanner isn't going to realize what just happened. It's just going to keep pounding the site with different vulnerabilities. And since we're stripping out every possible way to get custom input into the application, none of those vulnerabilities are going to come back successful. So somebody can run a scan for 10, 20 hours, especially since we're slowing down all the requests, and it'll come back and say there were 0 vulnerabilities, even though the site may have been vulnerable to half of them. So we're going to go to the security monitor, and I'm going to show you some of the information that we've collected so far. So we'll go into the sessions graph, and this gives me a list of every single user on the site right now. And you can see, here's my session right here, and I've been named Letha7001. So we're going to go into that profile, and you can see so far we're racking up quite a bit of information. We've got all of these different query parameter manipulations as well as a couple hidden parameter manipulations. And I can actually drill into any one of these incidents and see some information about it. So not only will we give you a readable description of what the incident is, how the person triggered it, and what they were probably trying to accomplish, but we'll also give you information about the exact values they submitted. So we had a parameter of M4, we expected a value of true, and we ended up with a value of not true. And also we record the full request and response details in case you want to do additional analysis. So let's switch over to the responses tab, and you can see all the different counter responses that we've been activating along the way. And again, these are all happening automatically, so the administrator doesn't need to ever use this tool to actually stop the threats, but we will show you all the different responses we're activating and allow you to manually activate them if you choose to do so. So we're going to go back to generic electronics, but I'm going to disable the slow connection because that'll make the demo take a little longer. So we're going to go back to generic electronics, and this time I'm going to go for the Htaccess file. And David had mentioned kind of the workflow of this in the presentation, but I'm going to show it to you in real life now. So the attackers generally look for a file called Htaccess, and the reason being the file provides a lot of really great information about how to attack the site. Most sites don't expose it, but there's a few that actually will. So it's always, kind of an easy step to just see if it's there and if it's exposed. And if it is, you've got a leg up. So we're going to try Htaccess. And what you'll notice is the site actually returns an Htaccess file. So from the attacker's standpoint, this is looking great. I mean, I've actually made some decent progress. But in reality, generic electronics is not serving out this file. It's being served out by the Mykonos appliance. So the next thing I'm going to try so I'm looking at the file and I see it says recover password.cgi is being password protected. That looks really interesting because if I can get to recover password.cgi, I might be able to actually compromise other accounts like the administrator account. But I don't have a username and password to even log into it with yet, so the next step is to see if I can get to htpassword, because I see that's also being referenced from this file. And convention generally tells me it's going to be in the same directory, so we're going to try to get to htpassword. And again, the server actually returns an htpassword file, so this is really good news, but maybe I have to stop here because I don't know how to decrypt these passwords. But let's say I do and I know how to use a tool like John the Ripper, and I throw this file in there, and a few hours later it comes back and says that the password for Barton is Trapper. So now that I've actually compromised an account, I can go try to log into recover password and see if I can actually recover somebody's password. So we're going to go into recoverpassword.cgi. And again, you'll notice I've been slowed down yet again. So we'll go ahead and log in with Barton and Trapper. And I got a login dialog, so everything is so far looking exactly the way it should. But unfortunately, after I logged in, I ended up getting a 500 error. So what this tells me is the script is there, but it's not working, or maybe I'm not providing the right inputs to it. Either way, I might spend a couple more hours trying to feed this thing different values and hoping to get some sort of recover password dialog, but it's never going to happen because everything I just showed you is completely fake and generated by Mykonos. So I basically just wasted 8 or 9 hours of my time and didn't really accomplish anything. So let's switch back over to the security monitor, and we'll go to the incidents list, and you can see we've now got a full description of kind of the attack path this user has taken. So they started out with query parameters, then moved on to hidden parameters, and then finally went through the whole Htaccess path. So we've now designated Letha7001 as a very high threat because they've demonstrated the ability to modify URL parameters, use tools like Firebug to manipulate HTML, and also to crack encryption and passwords and read configuration files. So this is a pretty serious threat, and you want to deal with them pretty quickly. And if we go over to the Responses tab, you can see we've actually automatically issued a block. So now if I go back to generic electronics, I'm not going to be able to get to it. So not only is my connection going very slowly, but it now comes back and says, you've been blocked from this server, contact customer support if you need assistance. So, hopefully the attacker actually tries to contact customer support, and then you have their phone number. So I'm just going to go give you a few more examples of some of the responses we provide, and that should wrap up the demo. So we're going to deactivate all of the responses that are currently active, and I'm going to go ahead and manually activate some of these for the sake of the demo. So another response we have is the logout user response, which basically allows you to invalidate all of the sessions the user is currently using. So if I go back to generic electronics, we'll go to my shopping cart, which actually has items in it now, and I'm going to force the logout on the user. So you can do these manually, but again, everything is automated. So now as I go back to generic electronics and I navigate around, you'll notice my shopping cart has just emptied out. So you can use this particular response to pretty much invalidate anything you want, from sessions, shopping cart IDs, things like that. You can do it for authentication credentials, pretty much anything you want to invalidate. And I think I may have actually gone through most of these. So there's also the Inject Header, which we provide you. It allows you to inject a custom header into the requests coming from hackers so that your back-end applications can actually be updated to look for that header and then respond differently. And kind of the use case we provide for that one is, let's say you've got a hacker who's going after some sort of consumer electronics store, like generic electronics. So you might have it inject this header, and you could update your code in generic electronics to look for the header, and then let's say an attacker tries to make a purchase. You could pretend as though that purchase was successful and just kind of throw it away based on the fact that this header was there. So the attacker believes they've made a purchase, they kind of move on, but in reality you haven't actually allowed the fraud to happen. So that's completely optional, but if you want to integrate your back-end applications with the Mykonos appliance, you can do that. And then, I showed you slowed connections, strip inputs, which is break application. We also have the break authentication response, which allows you to break any authentication attempts the attacker may try. So if they try to submit a username and password, we'll automatically mess up the password so that every login attempt they make, even if it is with valid credentials, will always come back with the invalid password message. So kind of the use case there is you've got somebody who's brute forcing your login dialog. We activate this response automatically, and now their brute force tool will complete all the way through testing every single password and username in their dictionary. But even if it would have gotten some right, it'll come back and say it found absolutely nothing. So that pretty much wraps up the demo, so I'm going to hand it back to David.
Great. Well, at this time, what we want to do is really open it up to questions and make it interactive. There's a bunch of questions that have already been asked, so let me start answering them, and please add your questions to the list, and we're happy to answer anything you want to know. So the first question was asked to explain the differences between Mykonos and a honeypot. It's a great question and one we get all the time. Honeypots, for those of you that are unfamiliar, are devices or usually servers that sit inside the network. And what they're hoping is that a bad actor, after they hack in the network, finds this appealingly named server and goes after it, and then there's a ton of logging information stored. The problem with honeypots is, as interesting as they are, they've always been very largely theoretical because you were always hoping that the attacker would hit your one honeypot and not the thousands of valid servers inside the network. The other problem with honeypots is they're inside the network, so you've already done the damage, you've already hacked in. So what Mykonos does that's different than a honeypot is Mykonos is not inside the network. We're actually injecting the code all the way down to the customer or hacker and putting it into the HTML. So we're not hoping that somebody hits our one server inside the network, and we're not waiting till after they've broken in. What we're looking to do, as I mentioned earlier, shift that detection all the way to the reconnaissance phase before the attack actually starts to happen. The next question was about demoing for customers. Absolutely. We'll give contact information at the end of this, and we're always happy to give live demos for anyone who would like to see more. The next question was, how are the hackers' names assigned? And there was a question as to whether there was a significance that there were two Tims. The answer is they're randomly assigned. The intent of having the naming schema is that what we want to make sure of is we don't want two people sitting in a security operations center shouting IP addresses back and forth. We really wanted to personalize it around a single computer versus 5,000 people that may be behind an IP. And so by having the names, we actually allows us to be able to say, hey, Tim45 is back on the site. What do we need to do about him? And we can actually start to see repeat attackers in real time. The next question was, there was a question about how the fact that we're very interactive and how do we make sure that we're not restricting false valid users and false positives. It's a great question. It's core to everything that we do. Mykonos doesn't suffer from the false positives because it's not built on signatures. So what we're not doing is saying, hey, if we see quote marks, this might be Sql injection like a traditional web app firewall would do. What we're doing is we're actually going and saying there are certain behaviors that a hacker has to do to hack a site. Right? They either have to manipulate your forms to do something like Sql injection, they're going to have to play with your URL string or your cookies to do things like session hijacking. There are very fundamental basic things that are behaviors, and those behaviors are consistent regardless of the actual attack vector that they choose and regardless of how they actually code it. Whereas a signature says, tell me exactly this specific attack type, we're looking for that broad-based behavior. And because the attacker is touching things that aren't real, we don't have the false positives that you'd have. All of the things that they touch are fake. And so by definition, somebody manipulating something that isn't real is a bad actor. The only question is, what sophistication level are they? And as a function of that, we really don't have that capability and don't suffer from the same issues that you'd have with a traditional security solution. The next question was the installation and the complexity of it. The real answer is that this is an incredibly simple installation. We showed you earlier Bertelsmann and Brown Printing. They deployed in less than 30 minutes. And it was immediately up in front protecting customers. One of the other big benefits is that with a traditional solution, you have to do what's called learning mode, where you're watching the flow of traffic and then somehow kind of magically trying to figure out what signatures to write based on that flow of traffic. And when you talk to customers, they'll tell you, hey, we had this web app firewall up for months and months in learning mode, and every time we update the software, we've got to update learning mode again. Well, with Mykonos, there is no learning mode, because what we do is we autonomously understand the type of code that's being run, regardless of whether that code is a third-party application like your SAP solution, regardless of whether it's written by a third-party contractor like a Wipro or Tata EDS, or regardless of whether it was built in-house 5 years ago or yesterday. We actually can inject into that code and intelligently match to our profiling to that code. So it's an incredibly simple installation. And typically what we're finding, and I'll give you a quick example from Mykonos' own experience. We just gave a presentation a few hours ago, and before that presentation, we wanted to see some of the traffic hitting our own site. We get a very little traffic to our website, and in the last week, 100 hackers were detected and stopped by the Mykonos appliance. So you can imagine that if you've got a customer in financial services, a large healthcare provider, you're going to see thousands of attackers on a daily or weekly basis. I've answered a lot of the questions of this next question. The question was, what is the difference between Mykonos and a web app firewall? And I've alluded to a lot of it, but the biggest difference is web application firewalls have really predominantly become logging devices to achieve compliance. And so under PCI compliance 6.6, customers were required to have either a web app firewall or an advanced code audit in order to be able to pass that compliance mark. And so because of the false positives, 90% of the people that run a web app firewall don't run it in block mode. They're purely using it to achieve compliance, and they're doing it by just letting it log bad actors, and then somebody at the customer side actually has to go through that data and try to figure out whether or not there was someone bad or not. Mykonos, by contrast, actually sits directly in front, and 100% of our solutions run in block mode. We don't require we don't have any false positives. We don't require you to modify any code. There is no learning mode. Everything we do is designed to be really light and really easy on customers. So we serve the same market, but I think the products couldn't be any more different in terms of what they're trying to accomplish. Our goal is not to just check a compliance box, although we meet the same compliance requirements. Our goal is to actually provide real-life security, because we think people are worried about being the next Sony, and that's where they need to spend their energy. The next question we had was, how do we size it? Very simple question. The Mykonos software on a single 1U appliance can push north of a gigabit per second. Then we have clustering if you want to do multi-gigabit deployment. So it's a very simple deployment. Very few customers, with the exception of your eBays and Amazons, are pushing multiple gigabits per second of web traffic, just pure web traffic. And so it scales very easily to handle customers of all sizes. The next question was, does Mykonos have a particular fingerprint that hackers can detect? Great question. Now, let me talk a little bit about what we're really trying to build long term, because every single thing that we detect is done by what we call a processor, and every processor is looking for a specific type of behavior. So every processor has three types of variation. The first type is that when a customer installs Mykonos, all of the things that we're going to be injecting are randomized at install, so no two customers look the same. And that way a hacker can't just write a script saying, let me see if Mykonos is here by looking for a specific injection. They're never going to find the two things the same. Second, we want to make sure that even we weren't going to be able to detect what a customer is going to inject. So our customers actually have the ability to modify what's injected so that they can do something that might more customize their site, or they can inject things that not even we would know about. And then finally, long term, we're going to open up an SDK that allows our customers to build their own processors to detect things we haven't seen, and even to countermeasure in ways we haven't considered. So in a few years, you're going to see a device that is literally a weapon that a hacker will not know what it's going to inject or how it will respond. And we think at that point, the game switches from hackers being on the offensive to hackers being on the defense, and that's really the whole point. The next question was, is there console access for SSH or Telnet? We actually do supply a console access. We also supply a full command line interface that allows that. We provide documentation on, so you can actually go in if you want to extract the data, if you want to manage it via the CLI, all of that data is accessible to you. In the next version, we're going to actually be exposing a web services API as well, so you'll have a SOA API you can actually code directly into on top of that. The next question was around competitors. And really, this is we think, a category of one product in the sense that this is the first product that is really designed around intrusion deception. We compete in the web application firewall market against companies like Imperva or Citrix or F5 that are making products that are all built around the same underlying technology, a technology that's an open source product called Mod Security, and it's a signature-driven rules engine. So all of the other products in the market are signature-driven. We're the first one that's not. And we think it's a differentiated solution. The next question is, if you sit in line, how's the failure of the appliance handled in high availability? Great question, and the way we think about high availability is that we actually want to be able to directly be encoded into the load balancer so that you immediately can have the system fail around Mykonos in real time. We also have our own failover mechanism built in, and we also support clustering. So multiple ways to achieve failover, but I think the commonality is we're a software-based appliance, and so it's incredibly easy to live in line and be able to directly stop attackers without having to worry about availability or taking down the website. The next question was about report-only mode. I'm not exactly sure what you mean by this. Let me take a stab at trying to answer it. I think what you mean is, do we have an ability to do like a span port where we sit in front but don't actually inject anything? The answer is we don't. We really think that the right way to be able to stop attackers is to be in line, and by nature of what we do, we're injecting things into the application stream. That is how we detect attackers, and so we have to be in line. The next question was, can Mykonos terminate SSL connections, and can it do it for a PKI-enabled website? The answer is yes. You can actually store your SSL connections directly in the Mykonos box, and in which case it'll do a full teardown and restructuring of the SSL. We also have an SSL pass-through mode where you can simply let the SSL go directly through the site. Both options are available, and both options are fully supported. So that is the last of the questions that have been asked. I'll give it 1 minute and just see if there's any final questions that you have. If there's any burning questions, happy to answer them. And it looks like there is another one. So the next question is about APT threats and how we can stop APT. Well, if you think about what an APT is, first of all, let me take a step back and talk about APT in general, because APT is one of those terms that everybody uses, but few people really understand what it means and what it technically means. All an APT threat means is an advanced persistent threat. It just means a hacker that is focused on your single company and is going to attack you repeatedly and try to get into the system. So that's the core of what an APT is. There is no specific attack vector an APT uses. They don't use consistent attack types. But the one thing that we are seeing from APTs, and there are really two forms of APTs we're worrying about. The first is we worry a lot about the Eastern European threat. It's mostly mafia-sponsored. It's increasingly been state-approved. There was a very famous case recently where there was a big hacker out of Russia. He stole $20 million. He wasn't prosecuted. And the message that was delivered, we think, to the rest of the hacking community was, this is an acceptable approach, and it's become a very large industry in a lot of Eastern Europe. The second thing we really worry about are the state-sponsored threats. Those are the ones that I think most companies are worried about. You saw it in the Aurora attacks. You also saw it in areas like the recent attacks that happened on CIA and other websites where it was believed to be in a state-sponsored attack. And so the way we think about APT is because APT is low and slow, they're going to go manual and they're going to go in your code. And the problem with APT has always been that you've got somebody attacking a single instance, and those systems are designed to look for volume. And so the reason they go low and slow in APT is because they're trying to evade a system that's saying, hey, if I get 50 bad calls, I need to flag this. Well, if you only get 5, it won't flag anything. And so what we actually do is by going out and injecting directly into the application stream, we can actually detect those bad actors, and we can do it regardless of volume. So Mykonos is probably the most effective solution against APT because we actually inject. We're looking for human behavior, we're looking for bad actors, and we're looking for it before that damage is done, and we're not predicating it on volume. And so we think it's a lot more effective. The next question was around latency, and do we add any latency? Really happy to say that in the newest version, we're all the way down to producing less than 4 milliseconds of latency. So for a web application stream that's real-time, that's doing injection, and that's with all of our processors turned on, we think that's pretty exceptional. So all the worst case latency we've ever seen is all about 40 milliseconds. So from a web app standpoint, that's not perceptible at all. So we think it's best in class. We've measured against competitive solutions, and we think it's superior right now. The next question was, are we on track to be GA by April 30th? And will it be Juniper branded? I'm assuming this came from one of the Juniper folks on the call. Yeah, Mykonos will be available to all 2,000 of the Juniper sales reps actually on May 4th. So that's when the actual release date is, right after the weekend. And it will not be Juniper branded early on. It's going to be Mykonos software, a Juniper Networks company. We've decided that we wanted to take advantage of the reputation Mykonos has built inside of the hacking and inside of the web app security industry, and we'll continue to do that. But we are a part of Juniper, and we will continue to be a big part of the Juniper security story. One of the things we didn't talk about, but just to mention, is that the intent is not just to use intrusion deception at the web layer, although that's where Mykonos started. We think there's an enormous opportunity long-term to take intrusion deception and embed it into our Juniper's SRX product, which is a network security product. We think there's an opportunity to integrate it into Pulse, which is an endpoint mobile product. Long-term, we think deception should live at every layer of the security stack. And the second thing is we're actually building, behind the scenes, a database of every single attacker. And you can imagine that these databases that have this type of specificity, this is the device and this is exactly what they've done, could be incredibly valuable to start managing this on a global level. And later this year, Mykonos will be announcing a global attacker database, a database that takes all of the data from every Mykonos device and rolls it up into the cloud and performs telemetry, performs analytics, pushes it right back to customers. And we think that we can enter an era of connected security. Because when you look at all of the major attacks that happened, the commonality is that every single major security company was in front, supposed to be protecting these companies, and yet they still got hacked. And so we think there's a need to do for the hacking world what companies did for the anti-spam world a few years ago, and we think that the Juniper Mykonos solution can be that version. The next question was around DDoS attacks. It's a great question. Let me answer this in two ways, because we think about DDoS in two flavors. The first is really true network DDoS, where somebody's slamming into, just ping flooding it, or other types of attacks that are very much network level. The right place to stop a DDoS attack that is network-centric is at the edge of the network. What you don't want to do is bring it through all of your network and put additional incremental latency across all of your network. So we think that the right place to stop network-level DDoS is at the network perimeter. But there is a second type of DDoS emerging, and Mykonos is involved in stopping these, and that's DDoS where you see application-centric DDoS. Somebody's repeatedly slamming into a function that you may have scripted poorly, or you have a third-party piece of software and there's one function that takes 15 seconds to run. Well, if you just pound that function repeatedly, you can actually take the applications offline. And we actually saw that a lot in the anonymous attacks where they did a great job of finding out where applications were running poorly and really pounding them. And we actually can intercept those type of attacks, use a Captcha processor to break in any automated script that's going to try to pound the site. So we can be very effective in application-centric DDoS. The next question was when we can demo in Asian countries. Mykonos will be available around the world, and so we can demo in Asian countries as of GA on May 4th. The next question was around the global attacker database, and it was the question about whether our customers willing to provide input for the global attacker database. I'm assuming this is another Juniper folk on the line. The answer is that the global attacker database is a two-way database. By definition, you want it to be bilateral because you want it to push up anonymized data. So it's not going to be a personalized database. It's going to be a database that says, this is a financial services company. These are the tags of the people hitting their site, and here are the bad things that each of these tags did. So it's a much different database than any of the threat databases that you may be used to, where you're looking at databases that are IP-based, and they say this one's 20% bad, and this one's 40% bad, and this one's 80% bad. Well, if you're an administrator, and I spent 10 years running a large software service company where I was on the customer side, and you look at these big databases that are just a list of IP addresses, and the question becomes, what do I do with this? What do I do with 20% bad? Do I block it or do I not block it? And what's the difference between 20% and 80%? Well, if you're an administrator, you've got to make a binary decision. I'm either going to block this attacker or I'm going to allow them. And so the difference between 20% and 80% in the world of an administrator is nothing. And so this is a database that's going to look very different than any database you've seen in the world. It's going to be a database of bad devices with certainty, meaning it's going to push it up to every single customer is going to be pushing up into the world of the cloud system. We're going to be performing telemetry, performing analytics, and pushing it right back in real time. So it will enhance the database for every single customer by doing two-way participation. So we think our customers benefit from that. There are only a few exceptions where they won't, specifically like the intelligence community in the U.S., and we'll have some options that support them as well. The next question was a question about pre-sales objections, and specifically, does Mykonos adversely affect your custom web apps? The benefit is Mykonos has a cloud version. You can literally point your traffic to it and immediately see the impact it's going to have on your web apps. All you have to do is change your Htaccess file, or change your file on your host file on your desktop, and you can immediately start pointing yourself through it and exactly seeing the impact it'll have. So it's very easy to demonstrate that the Mykonos appliance will not adversely affect your web app, and customers are going to be plugging directly into that and doing some sort of QA process alongside that. So it's extremely easy to QA the Mykonos device, see the impact, see what it's injecting, and show that it has no impact on an adverse impact. The next question was around IPv6 support. We don't support IPv6 formally today, although there's nothing technologically stopping us from doing it. It's something that we'll add over the course of the next few versions as customers start to be ready to have an IPv6 network. The next question was, is Mykonos supported on VMware ESXi servers? The answer is absolutely. Mykonos actually has native support for ESX. We ship an ESX version of Mykonos, so if a customer is running on the VMware stack, they can run Mykonos natively right alongside their other virtualized environments. They don't have to stand up a separate server to do it, so it becomes incredibly light from an infrastructure perspective. Our intent, by the way, is over time to add additional support for additional third-party virtual machines, so you'll see Hyper-V and Zen and other systems coming over time as the demand is there. So I think I've again reached the end of the questions. It's now 10:56, so we've just got a few minutes left. If there are no other final questions, I'll give it a minute, And otherwise, we really appreciate everyone's participation today. And by the way, while we wait for that, I'll share one quick story. One of the things Kyle didn't demo, but we actually just built is we actually built something so as a hacker is hacking a site, the system actually intercepts the native site, and it pops up a Google map of the hacker's location with a note that says, it looks like you might need a criminal attorney, and a list of criminal attorneys in the hacker's area. So we actually think that there's a incredible way to be able to show people not only that we can detect an attacker and that we can actually affect just that one person. And just recently, we had a blogger who tried to hack the Mykonos site after he saw some of our press. He actually went out and built a attack vector against the Mykonos site and blogged all about what he saw as a bunch of vulnerabilities on our site. We then went a step further, and we actually delivered a customized message down to the blogger. So when he hacked in, it came back and said, welcome back, John. We really appreciate your hacking attempts, but we should recommend a little more sophistication next time. And he wrote a great blog post blogging exactly about what we were doing and how he was also deceived by the appliance. So the customer feedback out there has been fantastic. And for all the Juniper folks on the call, we can't wait to get in front of your customers and start demoing live. We can do demos immediately. And second, for all of the customers on the call hearing this and partners, we really are excited about showing you for the first time some visibility into the hackers hitting your site. And so it's 10:58. It looks like we've ended the questions. So I just want to thank everyone again for their time today. Really appreciate it. I'm David Koretz. I'm the founder and original CEO of Mykonos and now the VP and GM at Juniper. And Kyle Adams, who's our Chief Software Architect, is on the call as well. We're always available to answer questions after the call. My email is just simply dkoretz@juniper.net, and Kyle's is kadams@juniper.net. So thank you, everyone, for your participation, and look forward to being in front of your applications in the near future.